Is it nice to be on this side of things as opposed to the other side of things?
Yep.
Yeah.
I can't remember, like, with your class, did you all have travel snafus?
Not a snafu, but it was
But-
low visibility when the roads weren't closed. That's why this was kind of
Okay.
relaxing. but,
Okay.
yeah.
Gotcha. Well, everybody made it in, I guess, so that was a good thing. So, all right, Ignacio will be here eventually, I suppose. So, want to go through, I've got, still working on your problem sets. I will get those to you again as soon as I'm able to go through and work through, score those, and get grades and things like that. It sounds like people are feeling pretty good about that, so I'll get those back to you by the end of the week. We'll get those processed so you can go through and take a look at stuff. We'll finish up, hopefully, fingers crossed, repeated measures designs today, and so we'll have that problem set out to you all. I'm making some tweaks on that. I've had it set in there that's not actually a good fit for some of the repeated measures design stuff, so I'm trying to go through and steal dissertation data from Adam to sort of work some of that in there. So I'm making some tweaks on that, but I'll get that out to you. If we finish today, technically the due date would be next Friday. Would you guys want some time to sort of work through those, sort of not having it next Friday, but the following Friday, a little more time to work on this? This is going to be a big set. Okay, we're going to do that. So this set 2 won't be due next Friday, but the following Friday. Other thing I'm going to do, I'm going to go through, well, I'm not going to, I didn't, random.org did, split you up into groups. So I'm going to have you guys work together on this set. So we're going to have CJ, Chris, Ken, and Nick working together. Gonna have Ignacio, Alicia, Chris M. You guys are gonna be in the second group, and then Sean, Tamara, Siley, you're gonna be in the third group. Okay. So going through like we did last time, have you all working together? Just need to turn in one assignment. The one thing I will say, just for helping you all kind of get together, understand kind of like the full set of things. Probably the more efficient way to do stuff is to say, all right, you do this problem, you do that problem, I do that problem type of thing, but then you're not kind of getting sort of looks at all the other stuff. So please, 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 as you're going through trying to figure out division of labor, try and work together, have everybody contributing to each one of these problems, just because each one of these problems is going to give you a little bit different look at the data, so a little bit different things going on, and so working together to so that you have a strong basis in some of these designs. We're going to get into some of the follow-up testing and stuff today. This gets pretty tricky, and there's a lot of different ways you could approach things. So getting some, what I don't want you to do is have done one thing and not have the opportunity to sort of really work through some of the other stuff. So work together, work in groups, sort of sit down, hash stuff out as you're going through doing that stuff. Does that sound good? Okay, questions on any of that stuff? All right, cool. So we'll jump into this. Sean, is that up and running? Okay, cool. So we left off last time talking about follow-up tests, talking about options for arbitrary contrasts, different post hoc tests and things along those lines. And so what I want you to do is pull out, because we're going to get plenty of SPSS work in eventually, but what I'd like you to do right now, pull out the handout for your ordered means. So your one-way repeated measure ANOVA, the ordered means handout here. Okay. If you remember, this was the data set where we had individuals coming in who were receiving inpatient treatment. And what we're doing is we're going through and following up at intake, 2 weeks, 4 weeks, and 6 weeks, right? And if you recall what we found, we'd gone through and worked on a screening, those data. Remember, we gave this handout, just kind of a summary of the screening. that things were looking pretty good there. These data were pretty well behaved, so no real concerns in terms of assumptions here. And when we've gone through and taken a look, can someone remind me what we found for this set of data? Yeah.
Over the 4 time points, we saw generally improvement.
Ignacio, will you shut that door, please? Yeah,
4
sorry.
time points, we saw generally improvement.
Yeah, we saw general improvement in depressive symptoms over the course of treatment, right? So things were going down through and moving along pretty nicely, right? So on our omnibus tests here, our test of within subjects contrast, we found that there was statistically reliable or a sort of pretty big effect, right, for within group effective session, okay? Nick, so we've got a within group effective session there, right? On our test of within subjects effects, we're looking at our greenhouse geyser. Can you remind me what was going on there? Or can you tell me what a real interpretation of that effect would be? How would you put that into words?
With our hypothesis test.
Yeah.
So putting it into words, the data were relatively out of the null hypothesis, which posited no change in depressive symptoms over the course of the 4 time points.
Perfect. Remember this effective within subject effect. The null hypothesis is that across repeated assessments, depression scores were identical, right? And we found strong evidence against that, right? Suggesting to us that, yes, in fact, we have some evidence of change across time, right? And if we go down through and we take a look at our graph, right, we see something that looks like there's no real question about what's going on, right? We're seeing a reduction in symptoms over time. Now, if you're looking at your handout, we see that test of within subjects contrast, right? This is where we see that contrast effect that we were talking about before, okay? What we see here tomorrow, when we're looking at that test of within subjects contrast, what are you seeing here in that box?
The linear seems to have the biggest effect.
The linear seems to have the biggest effect, right? And then sort of what else is going on here? What about the quadratic? What's the p-value on that quadratic? Also significant. What about the cubic? Okay, right? And so what we're seeing in this is that for these data, right, we've got a graph that looks, if this is intake 2, 4, in 6 weeks, we got something that looks like this, right? That's a little more exaggerated, right? Something that looks like that, right? Now remember, does someone remember what that trend analysis is?
Basically the fit of the data, what function is going to fit best, and I guess potentially like if this were to continue on, what pattern it follows the best. And in this case, it's
good.
Linear or less a straight line.
Yeah, and I like that description of a pattern, because that's with these designs, with the repeated measure anode design, we're not looking technically at change. We're not looking at some underlying growth function or things along those lines. What we're just saying is that, is this mean different than this mean, different than this mean? The only thing that our profile or our contrasts are doing here is just basically within subjects contrast, like we would do, and we would weight this out. That's saying, does this follow a pattern of a linear pattern? Does this follow a pattern of a quadratic, a cubic, so on and so forth, right? And so what we're seeing is that a linear trend looks like it's doing a pretty good job, right? But if we add some curvilinear stuff, that adds a little bit. We have a small p-value for the cubic. And so remember that so here's linear, this is a quadratic, that's a cubic, right? What we can start to do is start chasing p-values with these trend analyses and say, oh, well, that's statistically significant, so I'm excited about that. I'm going to sort of go through and interpret that. Do we have any reason to believe that reductions in depressive symptoms within this treatment group is going to follow some sort of cubic function? Not really, right? So even though, yeah, it kind of fits and it adds additional variability, I'm probably not going to put much stock on that, right? And even when I'm thinking about the quadratic, right? This is just saying that this is now true, so that's going to be a parabola. If we look at this in the big term, that's probably where that's going, right? But what I want to ask myself is, in terms of what we're doing here, is it worth getting this sort of complicated for the extra stuff? Chris M's shaking his head. I probably would agree, right? I think so that linear trend here, at least for this, is probably good enough to describe what's going on. We're seeing some reductions, right? Now, if you want to get into the actual change, right? The actual sort of derive a function for expected change over time, like a growth function type of thing, repeated measure of ANOVA is not what you should be doing, okay? That's where our growth models come into play. This is where our multi-level models come into play, our longitudinal multi-level models. Really, this example, repeated measures ANOVA is probably not the best way to do this. If you have these data, probably a multi-level model, like an HLM or a growth model, something like that, is probably the best way to identify or to analyze this, because that's going to give you something that's an actual growth function going on here. The trend analysis is just saying, is this mean different than this mean? Is different than this mean? Some sort of linear function. It's just telling you differences between things. Okay. So this is how one way we could, with ordered means, could go through and take a look at this. But I don't know. We're kind of just saying that there's linear reduction and maybe some quadratic, and then if you cubic, you're going to get crazy. But really want to think about how do we interpret this. Okay. So if we go down through and we take a look, and so we say, okay, that's fine. We see evidence of linear reduction. But I can eyeball that and see that that's going to be true, right? I don't need a statistical test for it. What might be, looking at this output, what might be kind of a good, kind of simple way to go through and sort of describe what's going on in these data? Because again, this is where it comes down. With these types of designs, you want to have a game plan, right? Anybody have thoughts? How about this? How many comparisons could we make in terms of means-based comparisons based on what we've got going on here?
Five?
Go ahead. Toronto? No?
That's 7.
All right. Remember how many means we got? Got 4 means times 3 over 2. We got 6, right? We could do 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, 3 to 4, right? Clinical folks in the room, are those all interesting comparisons to make? Or not, Chris?
I think that, at least for this this study, I would argue you would be most interested in the first session, because that's your baseline, that's where you're starting, and then probably most interested in the fourth. So that would probably be the best comparison.
Yeah.
The other two are kind of tough because you already have reductions of depression symptoms, so it doesn't really make a lot of sense to show that it's just like slightly more as you go.
Yeah. You're right in the right headspace, right? For this, right? And this, Ignacio, gets back into sort of your question about like, oh, you know, so what if we just look at all the different comparisons and see what's going on? Well, here, I don't know, there could be, right? I can imagine a scenario where this could be the case, but really, am I interested in reduction from session, so from intake to 2 weeks? Maybe. If there's something going on, if I have a question that makes that question important, but that would have to be very specific, right? Am I really interested in change from 2 weeks to 4 weeks? I don't know, right? Probably, if I'm just looking at effectiveness of this intervention over the course of 6 weeks, probably, I think you're right. Like, so where are we at? where do we finish, and what's the magnitude of that change, right? I know it's gonna, is there any concern about whether or not that's gonna be evidence for a reduction in symptoms over the course of treatment? With close to 400 people in the sample? No, right? So this statistical test almost becomes ridiculous to even worry about, right? And actually for this, I would make an argument, I'm not even worry about the statistical test outside of just using SPSS to get information that I'm interested in. Yeah, I can see that.
Yeah, so how in the social sciences sometimes we get nervous about the time frame because I mean we expose the study to external shocks that may change the phenomena inside of whatever we're studying.
Mm-hmm.
So you don't account for that.
I mean, we just recognize this. I think we'll probably frame that in a term of generalizability. Okay, for this set of people in this treatment setting, right? We're seeing a reduction over time, right? Now, if we've got a different group of people in a different facility with different staff, right? Are we going to see the same types of reductions? But at least in clinical science, this is why should we try and put an emphasis in empirically based treatments on manualized interventions, right? So this is something that isn't something special and unique happening in this thing. If we've got an intervention that's worked and we've validated it, hopefully what we've got is something that can be transported. So if you folks over here are doing this and you found a lot of success with it, hopefully you're keeping track, have some systematic approach so that we can take this and move this somewhere else, right? Now, if this was just rando stuff that, hey, we did some things, then that would probably be a less compelling study than if, hey, this is our treatment program, these are the elements, this is what we do, we could transport this to some other place, this is what we're seeing in terms of reductions, okay? So what I'm gonna propose that we do here is I'm just gonna look at, so we know that we have strong evidence for a change in means over the course of over repeated assessments. That's all our omnibus test says. But based on this, I've got eyes in my head. I'm not super confused about what's going on. I'm not going to make this more complicated than it needs to be, right? And so what I'm going to do with this is I'm going to go through, and I'm interested in one magnitude of pre-post, right? And then 2 effect size, right? So what I'm going to do is I'm just going to hijack SPSS and I'm going to run, if this is what I want to do, what I'm going to do is I'm going to run a t-test, paired sample t, pre to post, right? And am I interested in sort of p-value on that paired sample t? Not really. It's going to be massive, right? With 400 people, like the tremendous power that t-test has is huge, right? So I'm not even going to worry that much about it, right? But what that t-test is going to give me in SPSS, it's going to give me a point estimate of the change. It's going to give me a confidence interval around that change, and then I can use what I'm getting out of that to calculate an effect size and sort of pull together an interpretation there. Okay. Questions about how we're approaching this and why? Okay. So if we think about gross. Whatever. So if we go, no, that was the wrong thing to do. No. Whatever. Okay. So if we go down through, take a look at this, right? Our game plan here, determine magnitude of pre-post reductions in depression, right? And so what we've got here is we've run a paired sample t-test, looking at the difference between BDI at 6 weeks, BDI at intake, and if we go down through, we see that the average reduction, we've got an average reduction of close to 18 points, right? Anybody work with the, so we've got our point estimate, but you also get, by just running this paired sample T, we get a lower and upper and lower bound, confidence bound for that, right? And what this is nice is because what we can do is we can say, okay, our best guess for people going through this treatment program, our best guess is that they're gonna have about an 18-point reduction in symptoms, right? But that reduction, our population estimate could be anywhere from about 16.5-point reduction to 19-point reduction, right? And if we're thinking about treatment applications, this is really, really important, right? Because if I run an intervention study, right, and I say, oh, and we often don't do this, right? Like, people going through this intervention can expect this magnitude of reduction in terms of scales that we all use, with population estimates ranging anywhere from here to here, right? So we can go through, and we've got that just right out of our output here. We can also go down through and we can run an effect size. Here, what we've done is we take a point estimate of the average change divided by the standard deviation of the change score, right? The reason I've done this, why did I do it? Why did I choose standard deviation of change as my standardizer here? What do I follow up here with? Confidence interval around D, right? And remember, if we're working with paired sample tests, if I want to calculate a confidence interval around that effect size, I need to use a standard deviation of the different scores, right? The standard deviation of the different scores is what goes into calculating my test statistic. That test statistic is what I use to get the non-centrality parameters for the upper and lower bounds of that to back transform in. And so if I want to calculate a confidence interval around a within subjects test, this is automatically my standardizer right here, right? So we've got, here's our p-value, s-value, base factor. Those are massive, right? Those aren't even really worth talking about or mentioning. They're just so huge. And we didn't need to run an actual inference test to know that we were going to get reductions, right? But we did it so SPSS gives me statistics that I can go through and use here. So we've got calculate our effect size, which ends up being 1.4, so we can say we're seeing on average about a 1.4 standard deviation reduction in scores from intake from pre-treatment and post-treatment. That's massive, right? Confidence intervals based on our upper and lower non-centrality parameters. So on the low end, we've got sort of lowest estimate for our effect size that's supported by these data is about 1.25 standard deviation reduction. Are we still happy about that? Yeah. Worst case scenario, we still have a massive effect size, right? And so what we do is kind of take this and pull together something that ends up being a meaningful description of what's going on with this omnibus test. Remember, our omnibus test just says that, hey, there's the means across repeated assessments are different. This pulls it together and starts providing some context, right? So we say, follow-up analyses indicated an average reduction of 17.8 points on the BDI-2, population or estimates ranging from 16.5 to 19.1. I flipped around with the signs because signs are arbitrary. So talking about reductions, right? So what I'm doing here is communicating just the magnitude of change, right? So any clinician can go through and say, oh, people on average who are going through this, at minimum, a 16.5-point reduction in scores. That's pretty big, right? Response to this study exceeded conventional benchmarks for large effects, with patients demonstrating 1.4 standard deviation change in scores over the course of intervention, right? Lower bound estimate of the population effect of these data continue to support reductions in excess of 1.25 standard deviations. Right? So this is just me saying, like, hey, not just are we getting an effect, right? It's not like, is change different than zero? Like the level, which is what this is saying, right? This is just saying is change different than zero. Yeah, it's different than zero. What we're trying to do is communicate, like, we've got really, really impressive effects going on, right? Results offer substantial support for large and clinically significant change in global depression for individuals receiving inpatient care. So we see, everybody's seeing questions about sort of what we did, kind of tying all this stuff together. Yeah.
Is it worthwhile to mention the time frame that you would expect to see the change, or since you're talking to clinicians, it's better to not?
Yeah, you could work that in there.
Okay.
Right? And just talk about this 6 weeks of inpatient treatment with, anybody done inpatient stuff before?
Like worked in.
Yeah. 6 weeks is a massive, massive amount of time for it. Usually, the time people spend in inpatient units is long enough so that they're not in acute danger to themselves and then sort of back out. So this is a private hospital. So we're saying, like if you give people that level of care for extended periods of time, so we're seeing massive reductions in output. Yeah.
Inpatient is you stay in the facilities, right?
Yeah.
Right.
So don't need to worry too much about this, but just trying to sort of talk about like how we can take sort of what we've got to really communicate something meaningful, right? In general, right? This is often the type of sort of description that we get for a follow-up test like this, right? Follow-up tests indicated that reductions in overall, follow-up tests indicated significant reductions in overall depression, which is true, right? Are we happy with that description? Right? You're shaking your head, no, Chris. Why? Outside of saying no just to make me happy.
That's half. The other half is
It
that.
counts for at least 50% of the variability.
Yeah.
Right?
It doesn't really tell us about how big the reductions are.
Yeah.
It doesn't really give us much information to confidence intervals or sample size or anything. It just says that it goes down, which is fine, but it doesn't tell us how much or how important that change is.
This is a lot more, but I feel as though this is communicating much more information and important information for the question at hand, right? And so we could do that, but we don't. It's basic. We want to hear about it, right? So this is a much better thing. My job is to talk about like, hey, like this is what we're seeing. This is what we can infer based on the data. Like this communicates a lot more information. Okay. Questions about how we would have addressed so this reduction for our ordered means. Okay, cool. Let's grab the one-way beliefs rating handout. Okay. So as a reminder here, in this scenario, what we've got are ratings. So we've gone through, asked people to rate vignettes of hypothetical survivors of stressful events, some traumatic, some non-traumatic, in terms of their willingness to maintain friendship with these individuals. Okay? And so what we did is we went through, these data are actually a mess. We'll go through a screening of those, you'll see how much of a mess it is. We ignored that and just ran our one-way tests here. And Alicia, what did we find for our test of within subjects effects for this example?
The rating was rating mattered.
Yeah, the rating mattered. The average rating across vignettes within individuals was different, right? The mean difference across ratings was not all the same, right? You're sick, I'll quit picking on you. Anybody, so what do people remember in terms of, what was sort of interesting as we were going through this, and we say, oh, what did we see when we were looking at mean ratings across these individual vignettes?
They were all pretty similar.
They're all pretty similar, right? But if we go through, if you go through and look at your descriptives, we've got average ratings across vignettes ranging from 7.13 to 7.65. That's not too much variation, right? But with this sample of, how many people we got here? 231, we have very, very, very strong evidence of differences in mean ratings across repeated assessments, right? Now, if we're looking at our test of within subject effects, if we go down our test of within subjects contrast, right? Our profile analysis, or our trend analyses are, what are we seeing, Chris M, in terms of trend analyses here?
In terms of fit, linear is probably not the best one to go with. You probably see more interesting results with either quadratic or cubic fit.
Okay. What about if you're just looking at the significance ratings on that within subjects contrast? What's going on?
They're all significant.
Most of them, yeah.
Except for linear.
Right.
But you can still make them.
Oh no, linear is.
Linear is?
Yeah.
Linear is, and then quadratic and cubic aren't, and then sort of the rest of them are, right?
Yeah.
So their p-values fall below threshold, Can we interpret any of these trends? What's that?
Not really.
Not really. Well, I would.
I guess you could.
It says order matters, right?
What's that?
It implies order matters.
It implies order matters, right? So can we interpret any of these? So I would not accept Nick's response of not really in favor of a hard no, right? Because this is just different vignettes. We can order these around any way we want, right? The order doesn't matter. And because the order doesn't matter, our trend analysis makes no sense whatsoever. It doesn't matter sort of what, and so this is the thing, right? Someone wants to go through, and all of a sudden I'm trying to interpret a seventh order polynomial trend for these data. It is, unless we have ordered means, this trend analysis is ignore it. It doesn't make any difference, right? Because if I switch these order of these things around, it's going to give me a different sort of results and things along those lines, right? So I'm going to not even look at this because I don't have a natural order to what I'm looking at, right? But if for our ordered, our repeated ordered assessments, right? In the last one, probably a multi-level model, a growth curve model or something like that is going to be the better way to look at that. But for this, now all of a sudden, this is where your repeated measures ANOVA has a place, has a time to shine, right? Because there's no real order. What we're interested in is truly differences in the means across repeated assessments, right? So if we go through and we take a look at the ratings for this, right? We're kind of all over the place. We've got kind of a zigzaggy pattern, but if we would have entered them into SPSS, it would have been a different zigzaggy pattern, right? And so what we need to do, how many different ways so all our omnibus test is saying is that these means we have evidence that these means are not identical, that the population means are not identical across vignette ratings, okay? How do we go through and approach this? What do you think, Sean? Like how might we dive into this and start to try and figure stuff out?
I guess you could do brute force paired t-tests.
Right, we could do paired t-tests, right? And so to go through and look at all possible combinations, right? But how many, so we got 8 different means. How many individual pairwise effects do we have with that, possibly? What's that? 28, right? Now all of a sudden, going to Ignacio with some of the stuff you were talking about last, we got 28 different pairwise comparisons to make, right? That starts to get overwhelming. I don't know what to make of 28 different pairwise comparisons. Also, if I'm going to go through and I'm going to run 28 pairwise tests, what do I need to do with that?
Correct.
Got to correct for them. And now all of a sudden, correcting for 28 goddamn tests, like I'm going to have something that's so massive that it's going to be too much, right? And so for this, what I'm going to do now is this is where it starts to become important to start thinking about conceptually. I know means are different. Means are different in there somewhere, right? Conceptually, how am I going to deal with this? What are the differences that make the most sense to me? Okay. So in this situation, what I'm going to do is I'm going to pretend I had an a priori hypothesis coming into this, and my a priori hypothesis is that individuals will be less willing to provide maintain friendship to survivors of traumatic versus non-traumatic events. So this is my hypothesis, right? Because remember, 4 of these vignettes are things that are proper trauma stuff, right? We've got a sexual assault, we've got combat exposure, we've got natural disaster, car accidents. Then we've got 4 vignettes that are related to stressful things, but things that we wouldn't typically qualify as traumatic. So we've got financial loss, relocation, partner infidelity, and chronic illness. Okay. So we've got a lot of different things, right? But what we're doing is we're saying, okay, we think that in these data, there's some systematic difference in people's willingness to provide support, and it depends on the type of event people experience. And so I'm guessing that people don't know how to react to trauma. They have concerns and some stigma going on. And so my hypothesis is that people are going to be less willing to provide and maintain friendship to individuals who've been exposed to traumatic versus non-traumatic events. Okay. So what am I going to use to test that hypothesis?
And contrast.
A contrast, right? And what this is, and again, Ignacio, going back to some of your question, what's nice is if we're going through and we're taking a look at this, right? Now instead of 8 data points to work with, I can say these 4 are trauma, these 4 are not trauma, and I can go through and I can ask a question and run a test that's specific to something of interest to me, right? And so it's a nice way to go through, as we go through, right, 26 different possible pairwise comparisons that could be asked within this. I don't know about you, I don't want to have a discussion where I'm trying to justify and describe 26 different pairwise comparisons and give some sort of reason why these 2 didn't pan out, these 2 did, in some sort of theoretically meaningful way. It's too much, right? Yeah.
2 questions.
Yes.
The first question.
I'll give you one. No.
The first question, I had this question since last semester. What about this, the sampling rules? Because to me, when you are running ANOVA, you are making, you are making giving some conclusions, some assertions that not necessarily will be applicable to the rest of the population, unless you
and that's a methodological thing, right? And so here, with any study with college students or things that we do, right, that's the big question. Does this generalize? Right? CJ's looking at things in terms of like motivation and stuff like that with college students. College students are at a very different development point in their life than sort of adults, sort of things along those lines, right? And so the question is what we found. So if we find something, is this something that's useful, generalizable to other things, right? Us in clinical, so we go through and we have people who aren't maybe diagnosed with sort of whatever we're looking at, or sort of they're a subsample, right? Well, does that generalize? If I do stuff with trauma-exposed students at the university, the question is, does that generalize to combat veterans, right? And so then we start to get into conceptual argument of like, what have I done? What are my arguments for that? Is this phenomenon that we've captured, is this something unique to undergraduates at the University of Wyoming, happen to be in my sample, or is this tapping into something that looks like a larger phenomenon? So this is not a statistical issue, more so than a methods issue and a replication issue, and wanting to demonstrate that this thing that we found, we keep seeing it again and again and again, even if we look at it different ways, even if we use a different pull from different populations, right? Any one study is not good evidence of much of anything, right? But if we can go through and we can continue to show that it holds in a lot of different situations, then it starts to become more compelling.
Okay, the second question is, let's assume that I have an actual sample. I'm trying to come up with a statistical inference. So, but let's assume that when I collected the data, it was uneven, and I have to weight my data now. How it works with ANOVA? Should I weight first the data and run ANOVA, or run ANOVA, weight the data?
This is something that's a little bit different in terms of what works, operates as convention within psychological science versus other areas. We don't do a lot of weighting, right? Okay. All our samples are sampled with convenience, right? So, right, we're just sort of accepting the fact that we have samples of convenience, should be recognizing that we have samples of convenience, and then using that to provide context to our inferences, right? Now, if I'm doing epidemiological research, population-based data, and I go through and I get a sample and I find that I have underestimated or underrepresented some minority populations and things like that, and then I want to say if my goal is to provide, the whole goal of the study is to provide like actual population estimates, then I might start to weight certain individuals in that set higher than other individuals to try and sort of go through. And so census and things along those lines, that's a big piece of the methodology, not so much for us. This isn't something that we've gone through and worked it. It often ends up being a limitation, saying, we didn't get real representation of sort of this groups, and so what does that mean? Maybe it means something, maybe it doesn't mean. So, what we're gonna do here is we're gonna run some contrast, contrast, okay? And so I've got my work here popped up. So again, we've got our hypotheses up here. Here we're just running through our formula for our contrast, okay? Here with psi, got our formula for our contrast, okay? So how many people are within each group or within each set of means? So we got 8 total. How many in one and how many in the other? 4, right? So we're going to assign our weights to the first group, which is going to be our 1, 2, 3, and 4. These are our 4 trauma groups, and 5, 6, 7, 8, those are our non-trauma groups, right? So we can see in calculating the value of our contrast, if we've got 4 people in one group, 4 people in the other group, what's our weight for each one of those means? 0.25, 1/4, right? And so we've got -1/4 because again, my hypothesis is that people will be less willing to provide support to trauma survivors. So I've got -0.25 times the sum of mean 1, mean 2, mean 3, and mean 4, right? Plus, because I think people are going to be more willing to provide support to survivors of non-traumatic events. So again, 4 means in this group, so our rates is going to be 1/4 or 0.25 times mean of my group 5, 6, 7, and 8. Okay. Now if I run this out, I get a value of my contrast of 0.256. Siley, what does the value of my contrast represent here?
How your groups are weighted.
How they're weighted, and then so what does this value represent? What does that mean?
It's how your contrast? Or
Yep, it's a contrast. What's that?
How you're comparing the groups?
Yeah. And so comparing the groups, right? And so what is this 0.256? What does that mean? Someone help her out?
There's a difference in the treatment effect between the 2 groups.
Okay, perfect. Difference in treatment effect by how much?
0.256.
Yeah, 0.256. This is just the difference in the aggregate mean, in the combined mean of this group and the combined mean of this group, right?
So instead of putting -1, you plug in that number?
What's that?
When you do the contrast, sometimes you use a -1 or.
Okay, this is, so what you're talking about is the weighting here, right? So we've got 4 means, and so we've got -1/4 times the first mean, -1/4 times the second mean, so on and so forth. That means just sort of mathematically just kind of combining these together, right? And so if we do this, if we take -1/4 plus -1/4 plus -1/4 plus -1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, what do we get? 0. It tells us we have a linear contrast, right? And if we take the absolute value of -1/4 and the absolute value of -1/4, the absolute value of -1/4 plus the absolute value of -1/4 plus 1/4, 1/4, 1/4, 1/4, what do we get? 2. So we know we've got a standard set here, right? And so what we've done is this number right here is literally the difference in the aggregate mean of our ratings for our trauma folks, or our trauma vignettes and our non-trauma vignettes. And so this is saying on our 0 to 8 scale, we've got a difference across these 2 groups of about 1/4 of a point. Not that big. That's pretty small, right? But we go through taking the value of our contrast, and we can calculate the t-statistic using a formula that was presented in the slides. We got the value of our contrast over the sum of our squared weights plus the sum of our negatives, square of our negative weights here, times 0.766. Anybody remember where that came from? That's the mean squared error from our ANOVA table, right? From our within subjects. What is mean squared code for in ANOVA world? variance. This is just a variance estimate, right? Over the number of people in our group, right? And what does, Nick, what does all that down here give us?
Our standard error.
Wonderful, standard error, right? I just like standard error is a good answer to things. It gives us our standard error. It's just calculation of our standard error, right? We've got an estimate of the mean difference over our standard error. So again, negative 0.256 over 0.041, that's our standard error, gives us a test statistic of negative 6.244. Is that a big T statistic? That's a massive T statistic. Degrees of freedom, 1177. Again, pulled that from the greenhouse guide. Degree of freedom just kind of rounded down instead of up, because we want to say we have more degrees of freedom than we do. And so if we do that, we get a p-value for our contrast of 5.94 times 10 to the 10th, negative 10th. Our S value is 31. Bayes factor 2.91 times 10 to the 7th. Based on this, how would we categorize the strength of evidence against the null hypotheses based on these data? Strong. Very, very strong, right? Is that surprising to anybody? Not surprising to CJ. CJ's not at all. He's not fake. He's a stone cold killer. He's not surprised by anything. Could we be surprised by this?
Yeah.
Yeah, why?
You could be just based on the point differences that were.
Yeah, right? We've got an effect that's really, it's not big. Right? We've got a quarter of a point difference here. Now, part of this evidence for this effect is due to the fact that we've got a lot of people in there, right? Part of it is, again, speaking to the power of these repeated measures designs, to be able to tease out very, very, very subtle differences, okay? So we go through, we run our contrast, and then if we want to go through, we want to calculate an effect size. What we can do is I've decided here as my standardizer to calculate the average variance across my individual groups, right? So this is going back, if we go back to the descriptive statistics, we see we have a variance for the first vignette of 0.77, 1.79, 0.8. Basically, I'm just taking my variance estimates, taking the average of those, taking the square root of that to give me an average standard deviation, right? And so my D here is 0.244. Is that a big effect size? No, it's consistent with standards for small, right? So we were saying that our ratings for our two groups are differing by about a quarter of a standard deviation. So it's not very large, but there's strong evidence that it's not nothing, right? Then if we go back up here, calculate a confidence interval around the value of our contrast. So we got negative 0.256 times 1.962. Where did I get 1.962?
Critical.
Critical with what degrees of freedom?
Oh, 95%.
Okay, 95. So that's the sort of my confidence level.
Yeah.
What did I use to get the that specific t-value? What degrees of freedom did I use? What's that? Yeah.
Oh.
Same one I used for the test, right? So I got that, and then my standard error, I've already calculated standard error down here, gives me my interval estimate, right? And so I'm saying, based on these data, I'm seeing about a quarter of a point difference between my non-trauma group and my trauma group. But based on these data would be compatible with anything from a difference of about 0.18 to 0.34. Okay. So throughout all this, we've gone through and calculated questions on what I've done or the statistics that I've calculated. This is all kind of sort of refresher sort of stuff that we've done before. What's the one thing I haven't addressed to this point? And so my general interpretation of things.
It wasn't like the opposite of what you expected.
Oh, right? I mean, you would leap over Chris, give you a high five. Exactly, right? There we go. It's in the opposite direction, right? My hypothesis was that people would be less willing to provide and maintain friendships for hypothetical survivors of trauma versus non-traumatic events, right? But the fact that this is negative tells me I've sort of flipped this around. It's in the opposite direction. what we're actually seeing is people are more willing to provide, or at least in this study, are reporting greater willingness to provide friendship, continued support for hypothetical survivors of trauma versus non-traumatic events, right? And so this is where it's important. It's really easy to get lost in the nuts and bolts of calculating my statistics and what am I going to do and did I make the right, and where am I pulling my standard errors and so on and so forth, and forget that to sort of pay attention to direction and things like that, okay? So if we're going to go through and kind of tie all this, because we've gotten a lot of stuff, right? And how do we tie this together in something that is communicating something meaningful, right? So we say, plan contrast, comparing willingness to maintain friendship with hypothetical individuals exposed either traumatic or non-traumatic events, offer compelling support for incremental differences across event type, but in the opposite direction of that hypothesized, right? So I've got my T, got my P, got my S, Bayes factor, so on and so forth, right? As I was continuing to work with this thing, like, did we need to say significant or anything in there? It doesn't add any information, right? Like this, if I look at that, I know that's an incredibly small p-value, right? I know that that's a big S. I know that that's a massive Bayes factor. Right? I mean, I don't like identifying something as significant or not significant doesn't add anything to this, right? And so we say results found the participants indicated 0.256 unit reduction in willingness to maintain friendship will present with vignettes involving individuals exposed to non-traumatic versus traumatic events. Lower bound estimate for population difference indicated a 0.18 unit reduction in the upper bound supporting, in the upper bound, I don't know, does that make sense or did I screw that up? 1.8 unit reduction. The lower bound, okay, was a 1.8 unit reduction, with the upper bound supporting a 0.34 unit decrease in willingness to maintain support. Here's my effect size. Effect size of the point estimate for this discrepancy was small. So you get some 0.24 standard deviation reduction in willingness to provide friendship. So again, this is me just trying to put this together in a way that is not makes sense and kind of comes together and sort of meshes to something that someone can read it and sort of get a good sense for what's going on with my data, right? So we say results provide strong evidence of incremental reductions in willingness to provide support to hypothetical survivors of non-traumatic versus traumatic events. Although this effect was not predicted in initial hypotheses, it's also not clear the extent to which such an effect may result in an observable impact on behavior. What am I doing here? Providing context. Why am I saying that it's not clear if this is something that's going to have a noticeable impact on behavior? Yeah.
Just because there are, or we didn't measure we didn't have any measures about them actually providing support. It's just what people would like to think they would do.
Okay, right. So it's a hypothetical, right? What else? Why might I be couching sort of my conclusions here?
The value of the contrast is so small that you don't really know that that's a meaningful difference on this scale, and if that lends its way to
Yeah, my point estimate is a quarter-point difference on a 0 to 8 scale. That's pretty small. My effect size is small. We often work with small effects, right? So it's not necessarily a bad thing. I'm just saying it's sort of a smaller effect, and particularly the lower bound for my the lower bound of my point estimate for the actual difference, less than a 0.2 unit decrease from one to the other, right? And so just wanted to say, yeah, we're finding sort of strong evidence that it's not zero, but I'm still not positive that this is going to have a meaningful impact on anything, right? But then I'm going to say it's important to note, however, the methodological approach used in this study holds strong potential for socially desirable responding. So participants are more likely to report pro-social behavior in the absence of any actual cost, right? It's possible that the evaluation self-reporting willingness to offer support, hypothetical other may underestimate differences in the actual provision of support, okay? So again, this is trying to take what we've found and not just saying we have a significant difference or not, because that's boring and dumb, right? But it's not fun. It doesn't provide a lot of information, right? But what we've done is we say, hey, we have strong evidence that they're not the same, right? Basically, with this, like assuming that we've done everything right in correcting our data, like these data cannot exist if the null hypothesis is true functionally, right? But we've got a big sample, we're using a very, very powerful design, and so yes, they might not be exactly the same, but we have some questions about whether or not we've identified anything that's a meaningful difference. But given the context of what we've actually done, there's strong possibility that what we've done is actually underestimated sort of the difference in people's willingness to provide support to trauma versus non-trauma survivors, just given that what we've done is basically ask people to give us the answer that we want. The fact that they haven't is actually kind of telling in this, right? So again, spending a lot of time on this, but this is really kind of the most important piece of everything that we do. Does this help to kind of see how we might take some of these data and kind of pull it together into an interpretation? Anybody have questions about any elements or what I've added in there? Yeah, Sean.
Would it be wrong or data mining to try to come up with a theory that links 1, 3, 4, and 6, and then ties 2, 5, 7, and 8 together to try to make those two groups?
Hold on to that because we're going to do that in the next thing. Yeah. No, it might not. Like if you go through, if this is the first time we've ever done anything like this, that might be a reasonable question to ask, right? Like, so what's going on? We're seeing some highs and some lows. So what are commonalities and things along those lines, right? Again, if it's something that makes sense within the context of theory, do it, right? And so when we get into the next set of, when we get into mixed factorial design, we'll talk about some of the differences there. Cool. All right. Questions? Yeah, Ignacio.
Is there a repository you have in psychology where I can find the scales and some vignettes that have been used in studies?
Yeah. If I was, so these are data that we haven't published. It's the sort of, the idea is, and if I'm reporting well, right, I would probably, in an appendix or something like that, want to go through and say, hey, these are the scales that I use so that someone else could replicate, should go through and evaluate and things along those lines. Experimental is starting to have a pretty heavy push towards publishing, making data public, right? So if I go through and CJ publishes a paper, running a number of experiments, there's a pretty strong pressure at this point, right, to make those data public unless you've got a really good reason not to. And then, so that's good, right? So I might go through and say, oh, well, this is what CJ did, but I don't know, he kind of botched it all up because I'm not getting the same effects, right? But the same type of thing, this is in talking with Sasha in econ, right? Like a lot of the data sets that are used in some areas are publicly available, right? If you have enough money, or so you can go through and get them. And so someone else can pull up your stuff, run your analyses, and if they don't get what you got, that's going to come up, right? With us, it's a little bit different because we're collecting all our own data, but yeah, there is a push towards, one, methodologically reporting your measures and what you're using so that people can go through and get those, but then two, even so you're taking that a step further, particularly within our experimental arm, people publishing the actual data sets.
So is there a handbook or some place where I can find an index with the scales?
Oh, it's going through the study and the methodology and looking at sort of what they've done. And so if I'm using a scale that is widely and publicly available or not publicly available, it's proprietary, but here it is, right? You kind of know what it is. Yeah, it would be weird if Alicia's like, oh, I used this scale that I just made up for this study, but don't worry about it, it's cool, right? That would be problematic, and you would probably have trouble publishing that research. Cool. All right. Questions. So up to this point, we've talked about just our straight one-way repeated measures ANOVA, right? We've just got a series of repeated assessments, wanting to know, do we have evidence? Are there data suggesting that there are differences across these domains of my repeated scores, okay? What we can do now is switch over into a between by within subjects design. We call it mixed factorial ANOVA, a mixed repeated measures ANOVA. What we're doing here is we're saying, okay, so we've got repeated assessments, but maybe we've got a second variable, a grouping variable, a condition variable, where I've measured a couple different groups on the same measure across time. Okay? And so in the simple case, an A by B, repeated measures ANOVA, with repeated measures on the last factor. I've got a number of different, so there's 3 different questions I can ask here. Do my scores across repeated levels of factor A reduce measures? Okay, so let's say here I've got 3 groups, group 1, group 2, group 3. Okay, and I've measured each one of these groups on 4 different occasions. My first question here, do I see that group 1 differs from group 2 differs from group 3 if I just average across repeated measures? Okay. So if I take the average of group 1 across measures 1, 2, 3, and 4, that's giving me this value right here. Does this differ than the average value for group 2, different from the average value for group 3? What kind of question is this? Is it a between groups question or within groups question? Between group, right? I'm saying, if I collapse across my repeated assessments and just say, on average, does group 1 differ from group 2, differ from group 3? That's what I'm asking here, right? Other question I can ask is whether or not scores vary across repeated assessments of factor B, collapsing across group. In this situation, I'm ignoring group. I'm saying I don't care about group. I'm looking at the repeated measure of the mean of repeated measures for group 1, mean of repeated measure for group 2, or excuse me, assessment 1, time 2, time 3, and time 4. Ignoring group, do I see differences across these repeated assessments? And then what I can also ask, and so is this a within group question or between group question? It's within, right? And then, do repeated measure scores vary as a function of group? What are we talking about here? An interaction, right? And what do we call interactions?
Super fun.
Super fun, also super complicated and exciting, right? Often the reason we're doing this type of stuff, conceptually, what do we call it? If we have an interaction, that is what type of an effect? What's that? Yes, it is a conditional effect. What do we call conditional effects? Alicia, what do we call conditional effects? What if we have some factor that changes the nature of the relation between across another factor?
Moderator.
Moderator. It's a moderating effect, right? Do I see moderating condition? You've got the technical term. This is kind of the more, sort of, if you're saying, oh, this is a moderator, right? We're saying that we're asking here, does group change the pattern of means across our repeated assessments? Does this pattern of means differ across group 1, group 2, and group 3? Okay. So if we're going through and piecing this out, right? Again, portioning out variability, we start to, now we have between subject stuff, we got within subject stuff, and trying to tease this out, right? So here, first we've got the sum of scores total. This is the deviation of all scores from the grand mean. This is all the variability in our data, okay? This is at the top. This is the total piece of the pie. Technically, this is going to be the sum of the squared deviation scores of our individual scores from the grand mean. So if we went through and took this score from the grand mean, this score from the grand mean, this one from the grand mean, this one from the grand mean, boom, 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 like individual scores, squared deviations from the grand mean, this is the total variability in our set. Okay, total piece of pie. Same thing as it was last time, but just as a refresher. We kind of see this? Okay. Then we have, what we're going to do is thinking about separating our total sum of squares into between and within, just like we did before. But our sum squares between is going to involve the mean of our subjects minus the grand mean. And we're going to square that, right? And we're going to multiply that by W is going to be the within subjects factor, the number within subjects factor, right? So we're going to take 81 and subtract it from the grand mean. 230 from the grand mean. 101 from the grand mean. 225 from the grand mean, right? So this is our between subjects variability. On average, how much individuals are differing. This is again capturing that individual differences, right? If there were no individual differences, Sean, what would all these means be?
183.
Or at least within each group.
It'd all be the same.
They'd all be the same, right? But there's not. There's differences within here, right? This is the stuff that's getting sucked out of our repeated measures to make it a much, much more powerful test, right? Then we have our sum of squares group. This is the deviation of all our group means from the grand mean, right? So here, this is my group mean, deviation from the grand mean, group mean, deviation from the grand mean, group mean, deviation from the grand mean, sum of the square deviation scores here. This is getting the extent to how much variability or how much differences there are across our groups, right? And so we take our sum of squares group, that's a subset of the sum of squares between. Everything that's left over, this is our between group error. Okay? Then we got our sum of squares from our repeated measure. Okay? This is the deviation of our repeated measure mean from the grand mean. Okay? Repeated measure mean from the grand mean, repeated measure mean from the grand mean, repeated measure from the grand mean, and so on. Some of those square deviations. That's saying collapsing across group, are we getting differences? Are we seeing variability in these mean values across repeated assessments? So this is over here. Oops. Our sum of squares cells, this is a computational formula here. This is the difference in our grand, oops, up here for our sum of squares repeated measures, this is sort of these means. Or no, sorry about that. Group is going to be the group repeated measures from the grand mean. And then our sum of squares repeated measure by group, this is our interaction we get from subtraction here, right? So again, from the total sums of squares, we got the total piece of the pie, separating this into group, between group stuff and within group stuff. The between group stuff, this is going to capture that effect of sort of differences across groups, collapsing across repeated assessments. This here is going to be talking about this effect, right? Within subjects, this is the stuff that's happening within people. We've got a sum of squares for our repeated measure. That's going to get this collapsing across group. Do we see differences across our mean values? And our sum of squares repeated times group. This is our interaction. Everything that's left over is going to be our error term here. So people kind of see how we're breaking this apart. Okay. This is going to be important when we start calculating effect sizes for our generalized eta squared and sort of teasing out that stuff. So it's kind of confusing. So this is going to be, I think, where your eyes kind of glaze over. But sort of go back through, take a look at this, and sort of make sure that you have kind of good sense before jumping into some of that stuff. All right. So our mixed factor and our assumptions here. We have between subjects across individuals, across our groups. We're assuming normality. Why do I have that double asterisk? What's our normality assumption for our group for group-based designs? Yeah. Can you put that into words?
Normal distribution.
Normal distribution for what?
For the some of these are
Error.
The residuals.
What's that?
The residuals.
Residuals, error.
Well, hold on to that. Well, yeah, it's almost for the residuals for our group-based design. Are we concerned about the distribution of our observed scores? Is that no? Tomorrow, what are we concerned with? The sampling distribution, right? I can have nasty scores, right? But as long as I have reasonably sized the cells, or whatever I'm pulling from has a normal distribution of the population, that's what I'm concerned about, right? In general, now we're going to get into a screening thing where it starts to push on that, but yeah, I'm having, my assumption has to do with normality in the sampling distribution, not necessarily within the observed scores, right? And then homogeneity of variance across groups. I'm saying my assumption is that across each one of my repeated assessments, group A, group B, group C, population variability is similar. Okay. Then I have within subjects assumptions. Again, normality of sampling distribution, right? Homogeneity of variance across intervals, right? I'm saying that variability at time 1 doesn't differ all that much from variability at time 2, variability at time 3, and then my sphericity assumption. So we're just taking stuff that we've talked about in our between group stuff, combining with our within group stuff, and this is where we start to have some concerns. Like as our designs start to get more complex, we start to add in more assumptions, and then we start to get a little more shaky on sort of whether or not we violate certain types Questions on any of these? Okay. So, we are going to go through a couple different examples. Again, we're going to use some of the same data that we've used for the one-way. Again, we're going to use inpatient depression. So what we've got here is we've got scores at intake, 2 weeks, 4 weeks, and 6 weeks, right? But this time we're going to split our total sample into 3 different programs. So in general, like what we've said is we've got 3 different programs. We got one group that was in one program, second program, third program. Everybody's doing their own thing within their program. And so we're 3 questions we're going to ask out of this. Do depression scores vary over the course of the 6-week inpatient hospitalization? Nick, what's that a question about? Or what effect does that correspond to?
Collapsing across the groups, do the scores differ from over time?
Yep, that's just our within subject effect, right? Collapsing across groups, do we see differences in the mean scores across our repeated assessments? Then we got, do overall depression scores differ across treatment program? Nick, you're on a roll. What's this question?
It's between groups of the 3 programs.
Between groups, right? So basically, if I took average score across treatment for each group, so kind of collapse them, do I see group 1 different than group 2, different than group 3? Okay. And then last one, does the pattern of depression scores vary based on the treatment assignment? What are we talking about there?
What is interaction?
Yeah, this is our between, daily double, right? Yeah, no, this is our between by within interaction, right? Does the pattern of repeated assessment change depending on what group we're talking about, right? And this is often kind of the most interesting thing. This is kind of why we're going through stuff, okay? So this is, again, you're familiar with these data. Unordered means, again, same data set that we were working with before, but this time we're going to restrict it to our 4 trauma profiles. So ratings of willingness to maintain friendship, provide support to survivors of motor vehicle accident, combat, sexual assault, natural disaster. But now we've got 3 belief profiles, right? We've got one group of people that we assessed before who have generally negative beliefs about trauma, people who've been exposed to trauma, are unstable, crazy, and violent, right? People that have generally benevolent perception, people who have been through trauma are fine, they're resilient, so they're sort of good as they were before. And then a third group that has some interpersonal sort of concern. Like, yeah, no, they're probably pretty good, but I would be hesitant to have a friendship with somebody with them, or I would, I'd be hesitant to date somebody, or I'd be kind of nervous to be a coworker with someone who'd been exposed to serious trauma. So we got 3 different groups here. Okay. Questions about, everybody see what we've done to sort of take our one-way repeat and measure design and change it into a mixed factor ANOVA model? Okay, cool. Where are we at on time? All right, cool. Let's take a quick break and come back and jump into, we'll start with our ordered means. So pop up
Can you hit the
that,
pause button?
pull out your handout. This is the 3x4 mixed factors ANOVA screening. What we're going to do is we're going to go through real quick, kind of looking at these vignette data to see if they're anywhere near close to our requirements for our repeated measures design. So I'm looking at, I've got the repeated measures ANOVA belief rating data set open here. We're working with this handout. And so here's our data, but now what we're going to be looking at is we're going to be looking at our trauma vignettes, our 4 trauma vignettes, and then class rating. Okay. So what's the first thing we might want to do in terms of going through and starting a screening here? Yeah.
Screen for missing data.
Screen for missing data, right? And because this might change my data set, what I'm going to do before I do anything with my raw data, I'm going to go File, Save As, Scrap, or Working Set, or something like that, that I don't go through and nuke data that to never be recovered again. Never, never, never work on your original set. Always have a working file that you can go through, right? And so here in SPSS, this is what I do to go through, right click, sort ascending, we got disaster, sort ascending, assault, sort ascending. Okay, so it looks like we got all the values for no missing value for our vignette ratings. But we also have a class going on, so I'm gonna go through sort of sending, and I see that I do have missing values in class, right? So I can't include these cases if they don't have data available to them, so they're gonna get thrown out anyway. So what I'm gonna do is I'm gonna go through and I'm gonna record my numbers, right? I'll probably go through and actually just so they're in order because it makes me happy. Put those in order by sorting those in order and then go say, okay, so these are the cases that have missing values for class. I'm gonna mark that down on whatever document I'm using to keep track of things. So I can say, okay, these are the eight cases that were missing values for these class data. Okay? And once I've done that, you get rid of those because they're not going to be in there anyway. Okay? All right, so I've gone through documented missing data. What am I going to do next?
See if there are any plausible values.
Plausible values, right? And while I'm doing that, I can also ask for skew kurtosis values, things like that, right? So I'm going to go analyze descriptives. And I'm going to go through and I'll ask for MVA, combat, assault, and disaster. Because those are the 4 trauma vignettes that I'm interested in looking at. The other items aren't in there, so I don't care about that, right? And I'm going to go through and I'm going to hit save standardized values and variables. I'm going to go options. Request skew and kurtosis. I'm going to hit continue. Then I'm going to hit paste. Everybody hit paste. Let me do everything here. All right. Now this is going to give me descriptive skew and kurtosis and stuff like that. What am I forgetting here? What do I need to do before I start looking at distributions? Yeah. What do we need to do tomorrow? Yeah, split file. Why do we need to split this by file? Yeah, because I need to go through and take a look at things by group, right? Because something that may be an extreme value in one group might be dead center in the middle of the distribution for another one, right? So what do we need to do with our group-based analysis? We need to go through and run these by individual groups, right? So what I'm going to do is I'm going to go data, split file, and I'm going to organize groups by output by groups. And then I'm going to put my grouping variable in there, so class. So what this is going to do is while I have this split file on, any command that I ask it to do, it's going to do it separately across my individual classes. Okay. So I'm going to go ahead and hit paste, and then go back to my file here and put it in a place that makes sense. So I'm going to go through and first sort files by class, and then I'm going to run my statistics. CJ, what happens if I don't split my file before I start running my z-scores?
We're all like 5.
Yeah, it's going to run z-scores for using the mean of the whole sample as opposed to the mean of the individual group. So that's going to be problematic, right? So I'm going to go through first sort files by class, do my split file here, and then run my descriptive statistics. When I run that, this is what I get. So individual classes here, that's looking good, right? Siley, what's going on with, first off, do I have, again, this is a 0 to 8 rating scale. Do I have any problems with any implausible values? Nope. All look good. All my values are in range. That's good to know, okay? What might flag some concerns looking at these data? Yeah, Chris?
Your skew.
Yeah, what's wrong with my skew?
Oh, yeah.
What's that?
It's negatively skewed.
Yeah, in a big way, right? I got huge negative skew. What's my kurtosis look like?
That's also quite large.
Yeah, it's big, right? I got kurtosis values like 17, right? That's not good, okay? Again, rule of thumb-ish is things are less than 2 in terms of being like not terrible deviations from normality. But looking at this, before I even go through and pull up graphical representations of stuff, this data is going to be a mess, right? Already know, okay? So I'm going to go through, and we're going to go to analyze. Well, before I do this, first, I'm gonna go to Analyze, back down to split file. And I'm just gonna go through and say, analyze all cases, don't create groups. And I'm gonna paste that in, right? So this is just a command in my syntax file to turn my split off, or I can go through and just sort it, and then that turns it off too. So whatever you wanna do. So what I'm gonna do now, I'm gonna go to Analyze, Descriptives, I'm gonna choose Explore. And again, I'm gonna ask for MBA, Combat, Assault, and Disaster. And for my factor list, what am I gonna break this up by? A class, right? And I'm gonna take this subject variable, and I'm gonna drop it down into label cases by. Alicia, what's this gonna do? Never mind, you're not an SPSS person. Chris C., what are you doing here? What does this do?
So, which part, the class part or the whole thing?
The subject piece.
It will, if there's any values that fall beyond 1.5 times the interquartile range, it'll tell you which one it is.
Yeah, it'll should just kind of label those, so I don't have to, if I don't do this, it's gonna label those values by case number, and then you're gonna misinterpret that as the subject number and get you all turned around, right? Want to go through and do that, and then for plots, I'm going to turn off stem and leaf and hit histogram. I'm going to continue. Okay. I'm going to hit paste. Right. So what we're going to do is we're going to examine each one of our vignette ratings, split it up by class, asking for histograms and box plots. Right. Sean Ignacio, this is going to give us some redundant information with the descriptives, but this is just a quick and simple way to go through and get plots of each one of these things, which is nice. Okay. I'm going to go through and I'm going to run. Take it a while to think about it. All right. So, we've got our cases, and so this is just giving us a bunch of statistics, but we already kind of looked at the stuff that we're interested in looking at. We want to scroll down and just get our graphs. Yowza. Okay. Alicia, what do you think about histogram for the negative class for MBA? Yeah, clear negative skew. Same thing for benevolent class, clear negative skew. Interpersonal class, clear negative skew. CJ, how do you like that box plot?
So I don't like it very much.
Yeah, I don't like it much either, right? For two of our classes, the first quartile, the third quartile, and the median are all the same value of 8, right? And then they take everything beyond that is the extreme value, right? You got a little more variability in my negative class, but that doesn't look too good, right? What about combat? Well, that is also not great. That looks terrible. That's no good. Better than the last one, but still problematic. Assault for negative, benevolent, and interpersonal groups are no good. Again, that's looking gross, right? Same thing down here. Like, all that's terrible, right? So we've got big problems with our distribution. Now, we know, are we necessarily overly concerned with the distribution of our observed scores? No, right? Because our assumption is not with, our underlying assumption has to do with the sampling distribution, right? And what do our cell sizes look like for these data? Pretty good, right? But this is starting to push stuff that's reasonable to just sort of ignore, right? So I have some concerns with the distributions. So what I'm going to do now is I'm going to go back up, and I'm just going to go back to my table here, just because it's going to be faster. I'm going to highlight that. I'm going to repaste this, but this time I'm going to ask for ZMBA, Z-War, Z here, and Z here. Okay. Sally, what am I doing there?
You're getting your Z-scores?
Yeah, I'm looking for my descriptors for my Z-scores. I don't need to save Z-scores on Z-scores, so I'm going to get rid of that. And then I don't need skew kurtosis value. value stuff there, so I'm gonna just delete that, making sure, don't delete your period at the end, or otherwise it won't run it. Right, what I'm gonna go through, I'm gonna sort cases. Again, I'm gonna split the file once more, and I'm just gonna look at it and get basic descriptives for my z-scores by individual group, right? So we went through and run that. And so one way, and you should be attuned to this, to make sure that you've standardized created your z-scores appropriately. If I've done this appropriately, what should be the mean of my z-score within each one of my groups? 0. If it's not, you probably created z-scores before you split the file, and that's kind of screwed up, so make sure that you go back to and take a look. Tomorrow, what are you seeing in terms of these z-scores?
For all of them?
What's that?
Like for all of them?
Yeah.
They range from like 5-ish to 4.37.
What's that?
For for negative class, they're
Mhm.
ranging from 0.5 to 4.37.
Yeah, right. So we've got big negative z-scores, right? Suggesting that, for example, just in our negative group alone, right? We've got individuals who are scoring over 4 standard deviations below the mean for MBA, close to 4 standard deviations below the mean for combat, assault, right? We've got outline values here, right? So our distributions are garbage. We've got outliers, right? What's another thing that we should probably be checking in terms of our analyses here? What other assumptions do we have for this test?
Homogeneity of variance.
Homogeneity of variance, right? So we're assuming equal variances within across repeated measures and also across groups. Now, our Levine's test, our homogeneity of variance across groups, we'll get that in our repeated measures design or our repeated measures analysis. Those are sort of giving us strong evidence of unequal variances across groups. But we also need to be thinking about our equality of variance across repeated assessments, right? So on the last page of your handout here, if you take a look at that, I just sort of made this a quick table. As we go, now, if I go analyze descriptives, and I turn off standardized values and go to options, turn off security kurtosis and request variance, and I hit OK. It's just going to give me the variances of my, whoops, I need to do that by group. Analyze, descriptives, paste that. Okay. I'm going to do rerun this, right? So split file. Variances for each individual group. And so what I've done here on your handout is we see I've got 4 negative, benevolent, interpersonal groups. I calculated variances, or sort of pushed in variances at time 1, time 2, time 3, time 4, each one of individual vignettes. Okay, let's pull this up. Right. And what are these highlighted values here? These are my Fmax values. Okay. So remember, Fmax is just calculated as the ratio of the largest variance to the smallest variance. So what we've got is Fmax values for within group variance each time point, and then between group variance right here. Right. So we said Fmax we have some tolerances, but F max as large as 3 for unequal designs could be problematic, right? Now, within each one of these groups, across repeated assessments, do we have different cell sizes? Nope. So the negative people in the negative group, the number of people here, the same as the number of people here, same as the number of people here, same as the number of people here. So in terms of problematic variability across repeated assessments for each individual group, do we have concerns there? Probably not too much, right? But across groups at each assessment point, do we potentially have an issue there? Maybe, right? Our largest group is 94, our smallest group is 44, right? And so we have an unbalanced design, and so some of these might start to suggest that we have some problem. When we go down through and we actually run our homogeneity variance test, our Levine's test, when we run our model, we find that we have evidence of violations of homogeneity variance across groups in each one of those assessment points, right? So that starts to become a concern, okay? What's our last assumption with our repeated measure design? Sphericity. Do we need to worry about that? No, we're always going to violate that, so we just assume we're going to violate it, right? But in terms, so we've got big issues, right, in terms of these data. But one of the things we also want to do is think about, okay, not just saying, yeah, it's a problem, thinking about what the potential impact of that problem might be. If I'm looking at these data, right, we have 44 people in the negative group, how many in the benevolent? 94 in the benevolent group, and 85 in the interpersonal group, okay? So our negative group is our smallest group. Which is the group with the largest variance?
The negative group.
Our negative group, right? So in looking at, not just we have potential violations of homogeneity of variance, we've got a situation where our largest variance is in our smallest group. And so we were thinking about that overall ANOVA, that error term, that measurement of the variability within groups. Is that likely to be too big or too small? Too small. Absolutely right. Why is that, tomorrow?
Because it's not like weighing in the small group.
Yeah, right. So we assume in general that larger samples are better estimators than our smaller samples, right? And our ANOVA assumes that variance across groups and across time points is all equal, right? And so what it does is the overall, our aggregate estimate of within group variance is going to be weighted more heavily towards our benevolent and our interpersonal groups because those are bigger, and less towards our negative group because that has less people in it, right? And so if we're thinking about that in our omnibus test, that that error term is likely to be underestimating the variability that we have in our total data set because our smallest group has the largest variance, and so it's getting weighted out by these other ones, right? So our error variance is likely to be too small. What's that likely to do to our F values? Make them too big, right? And Sean, what happens when our F values are too big?
We might make assumption. We might deduce that it's the null is true and it's not.
Other way around.
No, yeah.
Right. If my F is too big, I'm gonna over-identify effects relative to what I should be identifying, right? My error is too small. My error is attenuated, and that's the denominator of my F statistic. So my F statistic is going to be too big, and what it's going to be is I'm guessing that I may have within these data, given the specific configuration here, I'm going to have too liberal of tests. I'm going to have tests that are saying that I have a significant effect when in fact I don't, right? I have something that, so I have less evidence against the null than I probably should if I hadn't made all these violations of assumptions.
False positives.
Yeah, I'm going to have, exactly. You know, I'm concerned specifically with this configuration of violations that I might end up with false positives. Right? So, in terms of writing up a screening, right? There's just a lot of stuff going on, and it just kind of makes sense given the design, right? I'm not terribly shocked given what we've done, right? But if we were to go through and run a screening on this, or I were to ask you all to run a screening on this, this would be a lot of things to go through and systematically identify, which starts to get redundant because there's just so much wrong with the data, right? So what second handout here is for your screening example for something that might look for a data set like this, right? So at the top we say we have 8 cases with missing value per class, identifying those cases, right? Say no evidence of implausible values, and proceed with the set of 223. We got rid of the people who were missing stuff there. And then in terms of distributions, right? What we would typically do is have for the negative class, we would have a description of this distribution and graphs for the MVA, for the combat, for the assault, and for the disaster. And then for the benevolent group, MVA, assault, natural disaster, accident. And then for the benevolent or the interpersonal group, this same type of thing, but that feels redundant, right? I don't need to describe all because they're all garbage, right? So you just say MVA, combat, sexual assault, and disaster ratings for negative, benevolent, and interpersonal groups all demonstrate pronounced screw and elevated kurtosis, right? Histograms all indicate negative prominent, negative skew. Box plots identified cases falling below 3 and 1.5 times your quartile range for all vignettes in all groups. And here, right, we're just trying to give a little bit of stuff. So we say max rating value of 8 identified as the first, second, third quartile for MVA, assault, and disaster vignettes in both benevolent and personal cases, right? Basically, we have very, very little variability, and everything that we do is negative skewed, right? Outliers, extreme values, again, there's a billion of them, right? It doesn't make sense to go through and list them all out. Homogeneity of variance, some evidence of potential violations of homogeneity across groups. This is based on Levine's test. Within group variability appears to be acceptable. Assume violations of sphericity. So in terms of recommendations, right? We've got missing cells, we've got unequal cells, we've got violations of normality and extreme values in our observed scores, violations of homogeneity of variance, and assuming violations of sphericity. Basically, nothing's gone right in terms of these data, right? So our options are to throw up our hands and say, well, if we can't do anything with this, that's probably not reasonable. So what we do is we're going to say, okay, what are our recommendations moving forward, right? So initial evaluation identifies 8 cases with missing values for class membership. Not a huge part of our sample, but we still want to go through, look through the record, try and figure out why those 8 cases are missing, right? Let's say all those 8 cases, all 8 of those cases were from our negative group. That might suggest that there's something systematic about our missingness in our negative group that could contribute to bias, right? So anytime we have missing values, we want to go through and provide some explanation for sort of what's going on with these values, right? Yeah.
On the other ones that we've done, you've had us list them out in like the groups that they were in. Would that?
Can you identify what group those are in? Grouping variables, what's missing, right? So we can, right? We can, now if we had vignette ratings that were missing, then we say, oh, we're missing these, that, for this, that, and the other thing. But here, the grouping value, so we don't know what group those people would go in. Probably, it's fine, right? And actually for these data, it's just sort of, some people didn't fill that out on the front end, it's not a big deal. But we don't know that based on the information we have. We could have systematic missingness going on right there. So we want to at least acknowledge that as a potential issue. We say violations of normality and observed friendship ratings, not necessarily problematic for underlying assumptions of the sampling distribution due to the size of individual cells. Mean ratings should also be robust to extreme values given the cell size and the limited range of the response scale, right? I mean, we've got extreme values. There are several standard deviations from the mean, but when your standard deviation is like this big, at the end of the day, we're not working with something like sort of income or something that could get orders of magnitude larger. Like at the end of the day, there's only so far away from sort of 8 that you can get. So it's not great, but it's probably okay, robust to that given the size of the sample. But what we have is concerns about what we've done is we've doubled up on the violations, right? So we've got problems with the distribution. Now they're all negative skewed, so that kind of helps us out some. Right? We've got violations of homogeneity of variance and an unbalanced design, which leads us to the possibility that our overall score or our overall error within our ANOVA could be too small, right? The larger samples are contributing more, or the larger groups are contributing more than the smaller groups. And so that sort of pooled estimate is going to be maybe smaller and underrepresent the variability in our smaller group, which could result in too liberal of tests. So recommended investigators, so basically everything going on here, probably transforms are warranted, right? At this point, there's just enough going on that we should probably go through and transform these data to see. It's never gonna make it good, right? Transform is just gonna kind of pull things together a little bit. It's not gonna change the ordering of the scores at all. It's always gonna be gross looking, but given the level and the magnitude of violations, it's probably better to go through. And actually the results we get out of the omnibus test differ depending on whether or not we transform and depending on what transform we use. Here, a reflected inverse transform does a decent job of trying to get it back together. I mean, once you're transforming data, then who cares, whatever. I mean, it's not real data in real scores anyway, right? It's sort of ordering things up. But that's probably what we ought to be doing with this type of stuff. But we're not going to. We're going to ignore it and just go through and run it just to save some time. But should be thinking about transforms in these data. Greenhouse geyser, assuming presumed violations of severity, and also if we're going to go through and analyze transform data, making sure that we're acknowledging that it's transform data and not transform the data and then pretend that we didn't and just talk about it as actual scores, right? If I'm talking about differences in the inverse or reflected inverse transform, as I'm talking about it, I need to recognize and say, well, we found differences in the reflected inverse transform or grading scale, just so everybody knows that we're not. This is what happens. People like to transform data and then pretend that they didn't and then talk about it if it's the actual scale of the original scale, when it's not. It's a different thing, right? And so making sure that we're acknowledging that. So this would be, in general, screening for these problems tends to be pretty, particularly with this, if we've got multiple assessments across multiple groups, there's just a lot of different ways to chop this up. But for these data, it's enough of a mess that we're just going to kind of truncate things down and say, hey, this is not a deal, right? Don't do this on your own. I'm not going to give you stuff that's this bad to go through and do, so your screen will probably want more detail like we would normally do. But if you think you've got something that's bad enough to go through and start streamlining stuff, talk to me before you make that decision. All right. Questions about the screening that we did for this? Okay, cool. So, we've decided that this ordered data is kind of a mess, but we're going to go through and run our analyses anyway. So, go through and grab your handout here that has the repeated measures ANOVA for your beliefs rating. So what we're going to do, we've gone through and we've cut out the scores that we're not, or the that we're not going to have here. And so what I'm going to do then, recognizing that I've got problems with this, I'm going to jump into the analyses. So I'm going to go down to analyze. I'm going to go, hold on, I'm going to sort this just to make sure I don't have a split file on. Okay. I'm going to analyze. I'm going to go to general linear model, down to repeated measures. And my factor, I'm going to name this rating. And how many levels am I within subject factor? 4. Okay. I'm going to add that. Okay. And I'm going to define. So what I'm going to do is I'm going to have my 4 trauma groups. So MBA, combat, assault, and disaster. Okay. These are my 4 ratings. Does it matter what order I put them in? No. We counterbalance all these ratings anyway, so they're all scrambled up when people fill them out anyway, so the order doesn't matter. Right? But what we're going to do now is we see this between subjects factors. I'm going to take class and drop that down into there. Okay. CJ, what is this going to do for us?
showing us our between subject stuff.
Yep, this is just gonna go through, before we didn't have a between subjects factor, so we just looked at the repeated measure. Here we're saying that we've got a between, so what if I had two between subjects factors? Just drop that down in there too, right? And then I have maybe a 2 by 3 by whatever design, right? This is just starting to get very, very large. Be very, very careful as you're planning these designs. Smaller is better, okay? Because they can get pretty intense. All right. So what we're going to do now is we're going to go through to contrast. You can go through and you see this is going to give us polynomial contrast. Can we interpret polynomial contrast in this? Trend analyses? No. So we won't worry about it. SPSS is going to give it to us anyway. To plots, okay? What we want to do is we want to have our ratings on the horizontal axis, right? And class as separate lines. And we're going to add that. And that's just going to give us a pretty weak SPSS plot for this, but it's fine. We'll sort of do the job of sort of giving us an idea of kind of what's going on in the pattern. So we're going to hit continue there. And then EM means, so this is our estimated marginal means. We'll just go through and ask for those just so we can kind of see it. Just kind of just breaks things down, gives us a sense of trend. So we'll hit that. And then we're going to go options. A request for descriptive statistics, estimates of effect size, and my homogeneity of variance tests. Okay, continue there. All right, I'm going to hit paste. All right, so here's my command for my thing. I'm going to go through and run this. All right. So, first thing we want to do is always eyeball this to make sure that what we have in here is what we would expect, right? So my repeated measure, I have vignette ratings for accident, combat, sexual assault, disaster. Okay, cool, that's what I wanted, right? Here, my between subjects factor, I've got 44 people in the negative group, 94 in benevolent, 85 in my impersonal. That squares with what we had done before, right? Down here we've got our descriptive statistics. Right? This is starting to get sort of larger, but in terms of, we've got our, within friendship, we've got our average rating for negative, benevolent, interpersonal, and then total, right? Same thing for our combat, negative, benevolent, interpersonal, assault, negative, interaction, negative, benevolent, interpersonal, same thing with disaster. Chris, for my main effect, my repeated measure, which means are being compared there? So just my main repeated measures of rating.
All right, so just for rating,
Yeah.
what means are being compared to the 3 groups? Or did I get that backwards?
Okay, so my repeated, what's my repeated measure effect?
Oh,
what's that
within.
telling me?
So within the subject.
The within subject. And so what means are being compared in that? In this table, what means are being compared in that repeated measure?
It's called your total of each of the 4
right.
groups. Yeah.
So it's this mean and that mean and that mean and that mean. So it's the total. It's the average. Collapsing across groups, do we see the average rating for friendship, combat, assault, disaster changing? Okay. And then between groups are kind of, we're not getting that in there, but this is a good thing. Looking at your output and being able to say, I know what this is and I know where this stuff goes is going to be super helpful. And it takes a little bit of time to figure it out, but it's going to make your life easier down the road if you can kind of identify what's going on there. Okay. So then we've got boxes tested the quality of covariance matrices. Ignore that. Don't worry about that. Multivariate tests. Same thing, it's just a different way of looking at stuff, but we're not going to worry about that. Don't worry about that. Test of sphericity, are we worried about that? No, we assume we violated anyway. Push that aside. Now we're down to our test of within subjects effects. Okay. What are we seeing here? Alicia, what are we seeing in terms of our effect for rating?
It looks like the rating supports, there's evidence to support the.
Yeah. We've got, looks to be some compelling evidence against the null hypothesis of equal, collapsing across groups, of equal ratings across vignettes, right? So kind of consistent with what we saw in the one-way. It looks like across our repeated, across our different vignettes, our null hypotheses that they're all the same. Looks like we've got pretty strong evidence against that, right? Nick, what do you, and again, we're interpreting our greenhouse guys are here. Nick, what about this rating by class? What's that telling us?
This is our, so when we throw the class into the model, looking at our within subjects effects for rating, so does rating differ across our repeated measures when accounting for the differences in class?
This is a moderation effect. We're going to spend a lot of time this semester talking about moderation. This is a moderation question. Anytime you see an interaction, it's moderation. And so tomorrow's, using tomorrow's language, which is generally quite blue, she swears like a sailor. No, so you're talking about this in conditional effect, right? Is our repeated measure of rating, or our repeated measure of effective rating, this is a conditional effect, right? Tomorrow, how do we know that this is a conditional effect?
Because it exists
Within the interaction, right? Because we have evidence, not strong evidence, but some evidence that the pattern, the differences in my ratings across vignettes is dependent on what group I'm talking about, right? So the differences that we're seeing across our repeated assessments are dependent on group, right? Same thing, just like we talked about last time. If you say, hey, I have an interaction of X and Y on M, what does that mean? It's like, well, differences in X and Y depend on M, right? That's all I need to know. If you say that, you're going to be right every single time, right? And so what this is saying is that the differences that we're seeing across vignette ratings are dependent to some degree on group level, right? Whether or not we're talking about a benevolent class, negative class, or interpersonal class. Not as strong as this, but if you just ask me, what are the differences in people's friendship ratings across these individual vignettes? Can I answer that? No? I say, I don't know. Or which class are we talking about? Because it depends, it differs, right? So we've got evidence of moderation here. We've got an interaction, again, saying that differences in ratings across our repeated assessment depend on sort of what class we're talking about. Now we're down to within subjects contrasts, or our trend analyses. Sean, can we interpret our trend analyses? Oh, yeah.
Mine didn't come out.
Oh,
on my SPSS.
Oh, it's you can look on your handout. It's on there. Yeah. Chris, can we interpret trend analyses?
No, it's not ordered.
It's not ordered. It doesn't matter, right? So this is all just stuff that's uninterpretable, so we're not concerned about that anyway, right? If we scroll down, we see our Levine's test, right? And this is just telling us that, yes, in fact, it looks like we have evidence for violations of homogeneity of variance across groups for each vignette rating, suggesting that we have problems of non-constant variance, right? Combined with the unequal samples and the weird distribution that kind of makes us nervous. The only thing that could make it worse is if we had right skew in some cases and left skew in the others. If they're all over the place, right? At least they're not. At least they're all skewing in the same direction, but it's still not good, right? Yeah.
Which one do you read?
It doesn't make. Actually, this is a good point, right? Generally, just sort of based on the mean, I don't think it really matters at all at this juncture. The one thing is that we know that Levine's test is sensitive to violations of normality. So the Levine's test based on the mean is probably not super valid anyway, but it's is kind of piling on, right? Like, oh, like this isn't valid because the data are all not normal. And also we have a really big sample, so maybe maybe these are sort of overly sensitive, but this is why we go through and calculate your F max too, right? So you're seeing at the biggest deviation in the ratio between the largest and the smallest variance in your screen is over 3, right? What was it? The largest F max was 3 something, right? I mean, so it's not good given the deviations in sample sizes, right? So we've got problems there. Now the last thing we've got down here is our tested between subjects effects. Now, honestly, when we're running these types of designs, this is generally not something we're terribly interested in. But what does this technically tell us? So if we look at our effective class, we have some evidence against the null hypotheses here, right? So we have something that looks like an effect. Can someone give me an interpretation of what this means? Yes,
Isn't this like the variability between participants, or is this?
Okay, no. Yes, you're right on. So with our one-way design, right? When we didn't have a grouping factor, that just said that people are different, right? And so it wasn't super interesting here. But here, now we do have a between subject factor, right? So it's not just people sort of all over the place. We have actual individual groups. So, but you're in the right head frame here.
What is the variability between groups then?
Perfect, right? Collapsing across repeated assessments. So if we take, on average, if we take the average vignette rating across groups, what this is saying is that we have evidence of differences in average vignette ratings across each one of our 3 groups. Basically, this is kind of like a one-way ANOVA for if we just took the average of all vignettes across groups. So if you take the person average across vignettes and use that, take that group average, this is just saying that on average, our interpersonal group is different than our benevolent group is different than our negative group. Now, oftentimes this isn't interesting, right? So going back to our depression data, right, where we've got group 1, group 2, or program 1, 2, and 3, right, looking at average depression scores across each of the repeated assessments, and we see differences across the 3 groups. That's probably not going to be terribly informative. But what about here? So I'm saying that on average, I've got difference in overall rating, vignette ratings, across my negative, interpersonal, and benevolent group. Is that interesting? Nick, you're nodding your head. Why is that interesting?
Basically says that their class or their belief system matters on how they rate, or their perceptions, how they rate these vignettes.
Exactly right. Right. We're seeing, depending on what your sort of general belief class is, whether I have negative view of trauma survivors, whether I have benevolent view of trauma survivors, or whether or not I have some interpersonal concerns, that makes a difference in general on how I'm rating these vignettes. That starts to become interesting and semi-important, right? But again, this is a conditional effect because we have a between by within rating, right? So we don't really know, right? But again, something to sort of note here, right? So again, for this case, it's interesting. For others, it might not be, but definitely wanting to go through as you're working through your output, making sure that you're noting each thing and saying, is this interesting or is it not interesting? And sort of knowing what you're looking at. So questions about this? All right. So we know that we have differences in average rating across vignettes over the course across the 4 vignettes. We know that those differences are dependent on class. Let's scroll down and take a look at our plot to see kind of what's going on. Just a general eyeball of this, Sean. What are you seeing? How would you just descriptively talk about? You're going to describe this to your grandma. How do you describe this?
That in general the negative and benevolence are similar.
The benevolent and interpersonal. These two are my benevolent.
The green and the green and the red, and that the interpersonal one is tracks the same, but they're different. It's different.
Okay, yeah, it's a long ways off. So what we've got is our benevolent and interpersonal are functionally interchangeable here, right? They're basically the same thing. Then we've got this benevolent group, or this negative group, that's generally kind of tracking the same, good point, right? But the overall profile is lower, right? And we seem to have a pretty big dip going on right here, right? So Nick, to your point, right, when we're interpreting that between groups, right, saying that we're collapsing across vignette, we're seeing differences across negative, benevolent, and interpersonal groups. Based on this, what do you think is going on in that effect?
It seems like that effect's driven by the negative group's rating of whatever we put in as number 2.
Right, so probably driven by number 2, but in general, my hypothesis based on this is that probably it looks like that negative group is reporting lower overall levels of willingness to maintain support than the combination of the other 2 groups here. So there's a lot of different things going on, and a lot of different ways we can go through and tackle this, but are people kind of seeing kind of what we're getting out of our omnibus tests here? Any questions up to this point?
Would you say there is an interaction?
What's that?
Would you say there is an interaction between the negative and benevolent?
Yeah, and we know there's an interaction because we saw it on the group by within interaction, right? And so looking at our graph, we can kind of see that probably where that interaction is sort of going on in group 2. What was group 2?
Combat.
Our combat vets, right? So it looks like people in general are kind of not keen on, or less keen, right? We're still high, right? But remember that this design is just pulling for people to say, oh yeah, sure, right? But even in that situation, we're seeing lower willingness of ratings to provide friendship to a hypothetical survivor of combat trauma than other people, right? So our question is, how do we go through? How are we going to go through and tease this apart? Like, so we've got an interaction going on. How many? Well, we've got 2, 3, 6. We've got 12 different means, right? If I was going to go through and take a look at all possible meaningful pairwise comparisons, that's going to take me forever. It's going to be a goddamn nightmare, right? Also, are all possible comparisons in this set of means meaningful? Tomorrow, why not?
Because we didn't have any hypotheses.
Okay, so we didn't have hypotheses, right? And so we're going to maybe pretend that we did, but so we'll take a look at that in a moment. But so we've got a between, by, within design. We've got a factorial design. I can physically, like God's not going to stop me from running a comparison between 2 means, but are all possible means comparable within this? No, why not, Chris?
You wouldn't have a reason to like compare, say, the negative class in rating or in the first rating versus like the benevolent class in the third rating. It doesn't make any sense.
Right. It doesn't make any sense to cross this stuff, right? So asking, is the negative class rating on MVA different than the benevolent class on sexual assault? Like, no reason to ask that, right? I can't interpret that even if there was, right? How many pairwise comparisons could we make? So let's start with just the betweens. How many betweens would be reasonable to make here? What's that? 3 at, so yeah, 3 between, but then we got 4 assists. So there's 12 between subjects, pairwise comparisons that could be made, right? So we've got 12 between. Okay, are people seeing that? So we've got 1, 2, 3. So we got 3 here, and another 3 here, another 3 here, and another 3 here. So we got 12 total, right? Now, if we were just looking at the average across, then it would be 3, but we know that that between subject effect is qualified by within subject, that between by within interaction. So we've actually got 12 there, okay? And what about our withins? How many within subject, or how many within subject comparisons can we make? 18, how'd you get that?
Yes,
20.
Yeah, right. So we've got 1, 2, 3, 4, 5, 6. So within each group, we've got 6 times 3, so we've got 18. 18 within, right? Gives us a total of 30, right? Who's interested in talking about 30 individual pairwise comparisons? It doesn't make any sense, right? So what we want to do is we want to have, so we know that based on our omnibus test, we have evidence that the pattern of ratings across individual vignettes depends or differs to some degree on class membership, right? So what we could do in this scenario, let's say that I didn't just run this for the heck of it, and I actually had some ideas about how things were going to turn out on the front end, right? And so maybe I have a priori, right? I say that combat is going to be less than all others, right? My hypothesis is that there's stigma against people who have been in the military exposed to combat trauma, and my expectation before I came into this is that on average people are going to be less willing to provide friendship and support, maintain friendship and support to members of survivors of combat trauma than, let's say, civilian trauma. Okay. How am I going to look at this? Yeah.
You have to do 3 claims.
Perfect. Right. I'm going to have 3 claim contrasts. And we're going to look at these at per comparison rates, right? I'm going to say I called this on the front end, so we're just going to run these 3 plain contrasts within each individual group. Okay. But if I'm looking at this, what else might I want to know? So now that these data have come out, what might I be interested in looking at?
It's benevolent, the combination of both benevolent and interpersonal from negative.
Yeah. I'm looking at that, I'm like, I know this is kind of zoomed in, right? But it looks like the benevolent and interpersonal classes are pretty similar across each of the vignettes, and that they're quite different from the negative, right? And so maybe under my exploratory, I might say that so negative is lower than my benevolent and interpersonal. Okay. So how many contrasts do I have with this? How many exploratory contrasts do I need to capture that? Yeah, Chris?
Just one.
Okay.
Oh no, I guess you would do it 4 times.
4 times, right? So I have 4 exploratory contrasts. And so, Ignacio, this is where some of these contrasts where we're combining groups starts to become very efficient, because it can actually get at the specific thing that I want to test, as opposed to looking at sort of individual pairwise comparisons across the board, right? So for this interaction, I like this set of tests. This kind of gives us a sense for what might be going on and sort of being able to talk about this interaction, okay? But I'm going to go through and I'm going to pretend that we started out and I had planned the combat versus all others on the front. So I'm going to look at those at per comparison error rates. What about my exploratory? What's going on with that? How did I come up with those?
After we already saw it.
After I already saw, right? After I looked at it already, right? So I'm making 4 exploratory contrasts, and I'm like, well, I got 4, these are exploratory, I'm gonna be a good person, I'm gonna identify those as exploratory, and so I'm gonna control for multiple tests, I'm gonna control for 4. Is that fair? Why not tomorrow? What's up?
Like you're doing something.
Okay, yeah. So, but these ones I called ahead of time. So I'm going to say, because I said before I even collected the data, like I think this is gonna, it's part of the reason I collected this, right? So I'm going to say I'm going to go through and take a look at those. Why doesn't it? If I'm being realistic, why is it problematic to only control for 4 contrasts on the back end?
We're just doing random all
Yeah.
by eye.
Yeah, I looked at it and I ran all of them, right? You'll notice I'm not interested in seeing whether or not benevolent and interpersonal differ on combat. Because that doesn't make sense, because I looked at them and saw those dots were right on top of one another, right? But I looked at it and I did it, right? And so you could make an argument that what I actually did and with our post hoc test is I can make an argument that I went through and I ran all the possible pairwise comparisons at each one of those assessment points and decided sort of based on that, oh, really what I just want to look at these 4, right? I could control for 4, but I didn't run 4. You make an argument for probably more that I ran 12, right? In my head, then I just decided to look at 4. Basically what I've done is I've cherry-picked the most extreme values and decided to go through and take a look at that. And this is where the post hoc stuff comes into play, is I need to go through, if I'm doing this properly, I need to recognize the fact that what I actually did is in my head, I ran a whole bunch of them and then decided which ones I wanted to do. If I only control for 4, I'm way undercorrecting for what I've got going on. Yeah, Ignacio.
A very quick question.
Yeah.
Just looking out of the bucket. Are we in a fishing expedition or?
Yes, right now we are, yes.
So how can you have to go back to the theory to justify all this stuff you did? Or you are allowed to go in that fishing expedition?
Well, kind of depends, right? What I'm doing is I'm saying that these are exploratory, right? But I may have reasons to believe that my negative group is going to be probably lower than my other group, just in general, right? Based on sort of my conceptualization of what makes these groups different, right? Now, I've identified these, and I think this is interesting because I can kind of explain and sort of test sort of why these things might be different. And Sean, this goes back into your question about on the back end, right? Like if I sort of start to come up with the theory of why the data are doing the things that they were doing, this is what I'm talking about. So I'm seeing what appears to be a very clear pattern with your overall ratings of willingness to provide help for among my negative group is lower than the rest of them, right? And I might say, well, what we're seeing is that this group sort of having negative beliefs about trauma and what it means, and so the impact I want to do is say, okay, do I have evidence? So are the differences I'm seeing, is this signal coming out that there's something real, or is this just kind of random stuff going on, right? And so what we're going to do is, what we want to do is try and find, yes, it's exploratory, a little bit of fishing, but it's fishing that makes sense. It's not just rando stuff to test just for the sake of testing. I've gone through and identified these things as interesting because I think there's theoretically, conceptually something there that I can talk about. Right? So what we need to do is we need to figure out how are we going to go through and test control for this. So if we go through, what people often want to do, oh, I'm just going to Bonferroni test this. Is that good? Nope. Why not, Sally?
Because it's a correction, give them a test.
Well, it's a correction. It's a correction, and that's good. But do we use Bonferroni for post hoc tests?
No.
No, it's going to be too conservative. It's going to be, in general, we don't want to just Bonferroni correct for stuff. And Bonferroni, my P would be, there's alpha about 0.004. Right, so, yeah. Same thing for Dunn-Sidek. That's not a post hoc test, that's for sort of controlling for a small number of plants comparisons. I could go through and I could maybe think about a Benjamini-Hochberg. The Benjamini-Hochberg is hard because I think about like how many, so I'm going through and I'm saying what I did is I ran 12 pairwise tests. Those aren't actually the tests that I want to run. I only want to look at 4. So it's hard to think about how we might institute Benjamini-Hochberg because it would mean running a bunch of things that I would then have to sort of test that I'm not interested in running that are pairwise, but what I'm actually wanting to look at is contrast. I don't know if that works. Okay. What's my other option for post hoc? What's our favorite post hoc test?
Tukey.
Tukey! We love Tukey, right? Can we do, is there an easy way to implement Tukey on this? No, right? Because we've got an interaction. Tukey is going to look at all possible pairwise comparisons, but or control for a specific number of tests, but I can't get SPSS to do this properly, right? So what I need to do here is I'm going to hijack Tukey, because we know how Tukey works. We can bend Tukey to our will. To go through and try and get something that's sort of reasonable for what we want to do. Okay. So with Tukey, what's the first thing we need to do with Tukey? You come up with R, right? How many comparisons are we trying to compare, or how many comparisons are we trying to control for? Well, we're saying 12 pairwise with the eye. I just came up with that. Pairwise. I'm gonna start a band called Pairwise with the Eyes. You guys are gonna think it's so good. Have a lot of trumpets. That's what makes for a cool band. It's a lot of horns. All right, so we got 12 comparisons, right? So if we're thinking about Tukey, right, we need to have, with a Tukey test, with a one-way test, we say, oh, we got 3 means, or 3 means that we're comparing, right? So if we're Tukey comparing, we say set R equal to 3. And if we set R equal to 3, 3 is our number of means, how many means are we going to compare, or how many means are we going to correct for if R equals 3? So we got 3 means, how many possible pairwise comparisons can we make with 3 means? Don't steal my band name, that's what you're writing down, aren't you?
I came up with my own band name. It's a brass band called Horn on the Cob. I just didn't want to forget it.
Yeah. Yes. All right, back to the question at hand. 3 means. How many mean comparisons do we have? 3. Perfect. Okay. So what we need to try and do here is get something that gets us close to 12. Okay. So if we have, let's say, R equals 5, how many comparisons are we? How many means are we controlling for there? Remember, it's number of means times number of mean minus 1 over 2. 10. Okay. Does that get us to where we want to be? No. Okay. So R equals 6. How many does this give us? 15. Okay. That's too much, right? But you can make an argument that the 12 that we're trying to sort of be conservative and correct for is already fewer than what we actually did, because we're actually running contrast and things like that. So given that this is completely exploratory, Ignacio noted that we're kind of on a fishing trip. I'm going to set R equal to 6. Okay. So I've got R equal to 6, and then what we need to do is we need to go through and we need to get our Tukey Q value, right? So if I go to the interwebs and I search Tukey critical value, right, I can come up with a calculator, right? So here K is equal to R, so I say 6. Now I need degrees of freedom. Okay. Okay. What do I do with my degrees of freedom? I don't know. I need to make a decision here, right? Because my degrees of freedom for my contrast is going to involve all the people in the set, right? But what I did, I looked at individual pairwise comparisons. These. right? What I could do, and what we're gonna do here is say, okay, what I did is I looked at pairwise comparisons, right? And I know that I've got differing numbers of people in each thing, so if I want to be conservative, like I'm just taking the most conservative path here, what I could do is go through and take a look and say, all right, well, in my smallest degrees of freedom for a pairwise test would be the comparison of people in the negative class, which is 44, and people in the interpersonal class. Right, so that's 44 and 85, which gives us what? 129, is that right? And what I could say as well, so if I, with a sample of 129, that gives me degrees of freedom 127. So if I'm being conservative, I could say degrees of freedom 127, okay? This is the most conservative test. Now I could also make an argument that what I'm actually doing is I'm running contrasts, and that's using the whole sample. So instead I'm going to use degrees of freedom 223, 221. That kind of feels like it's cheating because what I did is I ran pairwise comparisons and things like that. So I'm just wanting to communicate to reviewers that I'm using the most conservative approach possible. So I'm going to say 127 is my degrees of freedom. So I'm going to calculate it. So my 2-key Q for this is going to give me a 2-key value, 2-key critical value of Q equal to 4.10. Okay. So this is my 2-key, right? And that says that any 2-key test that I ran, we would need to have a test statistic that's 4.10, and if it exceeds that, then it's significant, meeting criteria of an effect at with a 2-key correction at alpha less than 0.05. That's kind of a pain to run through and run a bunch of 2-key things. What can I do with 2-key, that critical value? Remember, I can turn this into a T. Because 2-key and T have a direct relationship with one another, where T is equal to Q divided by the square root of 2. Okay. So what I can do is I can take that Q, turn it into a critical T. Right? So I turn that into a critical T. If I take 4.10 divided by the square root of 2, I get 2.90. So with this bastardization of 2-key, what I can do is I can go through and run my contrasts, and I can say that any value of my contrast, or any of my contrasts that have a test statistic that exceeds 2.91, I said that they're significant at 2-key less than 0.0 or less than 0.05. Comfortable with this, what we got going on here? Okay. So what we've gone through and what we've done is we say, all right, what we need to do is kind of reverse engineer some stuff to try and sort of build an argument for how we're going to go through, look at this stuff. And so in this case, this is a pretty conservative approach here. Really, if you look at, yeah, with yeah, and in the never mind. This ends up being a pretty conservative approach here. Okay, so people kind of seeing where we're going with this. All right. So first thing we need to do then is we need to go through and we want to take care of our a priori contrasts. Okay. So what I'm going to do tomorrow, where are we going to run our a priori contrasts? Or so what we're doing is we're saying that we're expecting lower ratings in the combat versus all others, right? And so what types of contrasts are these? These are within, right? So what I need to do is I need to go back through, and I need to go to analyze, analyze, and go to general linear model, and go to repeated measures. So I've still got my factor 1 is my rating factor, hit define. I got friendship MBA, combat, sexual assault, disaster, but I'm gonna get rid of class, right? Because I don't wanna look at these across class, I've already run those analyses. What I wanna do is I wanna look at these individually within each group. Okay? So I'm gonna do that, and I'm gonna hit paste. Now I'm gonna take my sort class command. And what I'm gonna do, or split file. So I'm gonna go through, I'm gonna split the file by class, and then I'm just gonna run a one-way repeated measures ANOVA model within each group separately. And that's what I'm gonna use to go through and break out these within subjects contrasts. Okay? So if I do that, hide that, and run this, you'll see that we have our one-way repeated measures ANOVA for our negative class, for our benevolent class, and for our interpersonal class. So let's go up to our negative class. So you see we've got 44 people here. We got our within subjects effects here, and we see that we do see for our negative class, we're seeing evidence of differences across our individual means. But what I can do first thing I'm going to do, calculate the value of my contrast. Right? So how many I thought I did it wrong, but I didn't. What's my weight going to be for my first set of means? Yeah.
Well, combat will be -1.
Combat will be -1. And what are the other ones?
There'll be -0.3 repeating, or +0.3 repeating.
Right, right. So we're going to say 1/3 times the mean for each one of my individual mean ratings in my output, which are farther up. But we're going to have 7.48 plus 7.39 plus 7.39. Minus 1 times 6.73. You'll see how we constructed that contrast there. So the value of my contrast here ends up being 0.690. So that's the value of my contrast. That's saying that within the negative group, that ratings of assault, disaster, and accidents are close to 0.7 units higher than ratings for the combat folks, the combat vignette. T statistic is going to be value of my contrast over square root of 1/3 squared plus 1/3 squared plus 1/3 squared plus 1 squared, right? That sum times 1.634. Where did I get 1.634 from? What is this?
Is that your T?
What's that?
Is that from the T?
Not from the T.
The mean
squared error?
It's the mean squared error. It's the mean squared error for the greenhouse geyser, mean squared error. It's my error term, right? And I'm pulling this from my one-way ANOVA table just within this group, right? So this guy right here. So this is my mean squared error. Over number of observations, 44, is going to give me a test statistic of 3.10, right? Do I claim, can I identify this as effect based on my Tukey correction? Right? Yep. 3.1 is bigger than 2.9, so I can say that yes, this is reaches sort of threshold for identification with Tukey alpha less than correction point less than 2.05, right? So we're saying that this is an effect we can go through and talk about, right? If I wanted to, so the actual p-value for this is going to be, we won't worry too much about p-values because we've kind of Tukey corrected for it, so we won't worry about that too much, right? But what we could also do is go through and calculate our 95% confidence interval. It's going to be 0.690 plus or minus my standard error. If I multiply that all out, that's going to give me 0.223 times 1 point. I think that's, so what is this value here? So my critical value. And I think I calculated that with 42 degrees of freedom, just because this is just, here, I'm not worried about significance testing or sort of what anything is. I'm just actually wanting to get the actual confidence interval based on the data that we've had. So this is going to be T-critical with 42 degrees of freedom, right? For this, which gives me a value 0.25 to 1.13. Saying that my best guess is that people are rating the willingness to provide friendship for combat survivor about 0.7 of a point lower than the other three, in the combination of the other three vignettes. But these data are going to support sort of a difference in the actual population ranging from about 1/4 of a point to a little over 1 point difference. We can go through and calculate effect size here. And what might we want to use as standardizer for our effect here? What do you think?
Generalized?
Oh, generalized data squared. That's an omnibus test. That's a measure of association for our overall test. If we want to just do it for this contrast, what might be a good metric for our standardizer? Yeah, our pooled standard deviation, right? Separate number of observations here, right? So we can just take the average, right? And so my average variance is going to be 1.047 plus 2.993 plus 1.313 plus 1.080 all over 4, which gives me an average standard deviation. Score is 1.608. Remember that we're averaging. We always want to average the variances and then take square root of that. If we just average to the standard deviations, that's going to give us a different number. We want to start with variances and work backwards, right? Which gives me effect size 0.690 over 1.268, and effect size 0.5. So what we've done here as we've said, a priori, I'm expecting ratings of willingness to provide friendship to be lower for my combat survivors than the combination of the other group, right? There's a contrast, so I can go through, once we work backwards, correct, because, oh, I'm sorry, do we have to correct for these? No, we don't have to correct for this stuff because it's a priori. So we're not worried about 2.90 yet, okay? This is stuff that we called on the front end, so we don't have to worry about correcting for this, right? So actually here, we can report p-values. We know that a t-value of 3.1 is going to be, so it's going to give us a p of 0.003, it's going to give us an s of 9, phase factor equals 22.7. Okay. So here, what's the strength of evidence of within our negative group that individuals are systematically rating willingness to provide support for combat survivors lower than a combination of other groups? Yeah.
Strong evidence against them.
Yeah, pretty strong evidence against them, right? It looks like it is, yeah. Assuming that the null hypothesis is true, assuming that combat ratings in the population are no different than the other ones, these data would be very, very unlikely, right? Questions about how we went through and approached sort of what we've got going on here. Okay. So what we would do is we would go through each one of these other examples sort of the same way. If you look at your handout, right, do the same thing for the benevolent, do the same thing for the interpersonal. And so what we end up with here is a situation where we've got our negative group, our benevolent group, and our interpersonal group. We got value to contrast, P, effect size, 0.690, 0.247, 0.180, 3, 1, 9, so if we go through and we take a look and are looking at this, right, we're seeing our biggest contrast here going on within our negative group, right? With considerably smaller effects in our benevolent and our interpersonal group, right? Now we have strong evidence of non-zero differences in all three of them, right? But it's looking like if we go through and look at confidence intervals around a point estimate of difference. For our benevolent group, we have a lower bound of 1/10 of a point. For our interpersonal class, we've got a lower bound of 5/100ths of a point, right? So the lower bound is pretty small in here. So we might question whether or not we have evidence of real differences in sort of those in that lower bound. But looking like we do have something definitely going on, at least for the negative group. Yeah, Chris.
Would it be fair to say that the benevolent and the interpersonal groups' significance values are being driven by the larger sample size?
Yeah, they absolutely are, right? And again, this is why it starts to become important and why thinking about practical impact, right? Do we have strong evidence that, yeah, those data are likely not zero? Yep. Does that translate into something that's meaningful? Boy, I don't know, right? We're remembering that the design is going for a strong response bias, right? So anything that I'm finding in here, I'm actually semi-impressed by. But in terms of strength of evidence, how confident am I to go out and say, this group is actually showing lower ratings for combat survivors than others? I'm fairly confident in the negative group, the other two, so I get trained that way, but I'd like to see more evidence before I sort of bet the farm on something like that. Another thing, in terms of these a priori comparisons, trying to help us get a visual of what's going on your output. This one.
Also, is there a way to like systematically compare these so that it's not just the numbers that are listed and you have to say it, is there a test that you can have to say it? And then we compare it, after doing this, we compare it to these three.
But that would be the interaction, right? Your interaction is saying and this is the tricky part, your interaction is saying so that that the pattern of means across across the repeated assessments is different across our groups. But it's not saying where it is, right? And so this is what ends up being such a tricky piece about going through and teasing these apart, particularly with complex designs, is you have to sort of make the argument for the differences are kind of spread out all over the place, but this is where sort of the true impact is going to be. Okay. All right, we're kind of at time here, or are at time here. These are just important designs, and they're kind of whose head is spinning maybe a little bit? Okay, yeah, ish, right? So would it be helpful? So we can do a couple of different things. We can, next week, finish up with some of these other, sort of finish up with this example, kind of talk about that, and maybe quickly run through the ordered means. That'll be a little bit easier. I could create a screencast from the example, walk through the ordered means, and you guys can really watch that, and so, which would get us into sort of regression stuff a little bit more quickly. I don't know, what are people's general thoughts or preferences? Do people have any? Okay. We'll go through, we'll at least start with and finish up this example in class on Wednesday, okay? So we'll at least kind of finish up how we might go through and tackle the between subjects contrast that we asked for. But if you flip forward in your handout, you'll see that these are ones that we just sort of request through SPSS, and that makes it kind of easy, right? So that'll be fine. I'll go through and create a screencast, so walking through the ordered means example. It's going to be a lot of the same types of stuff, so it may not be. I don't know that we need to, with the ordered means, that we need to necessarily go through the whole sort of demonstration and sort of stuff, but I'll go through and put together a detailed screencast that kind of walks you through that example so that you can go through and kind of see and get some practice in terms of calculations and stuff like that. And then that's kind of nice, you can stop it and rewind, sort of take a break so that I'm not yakking at you the whole time, right? Sort of those types of things. Okay. So we'll do that and then move forward. So what I'll do is I'll get the problem set posted. You guys get together in your groups and start sort of getting a head start on it, but we'll just be kind of flexible and when we'll have that one due. Sound good? Awesome. Thank you, folks.
Ignacio, you weren't here for this, but you're on the team with Alicia